Hello, I am Dr. Smita Narwal. Today we will have a look about the hydrodistillation assembly used for the isolation of volatile oils from crude drugs. Volatile oils are also known as essential oil, and these are the chief constituent of a variety of crude drugs like our spices such as coriander, fennel, cinnamon, clove, etc. Different parts of a hydrodistillation assembly includes heating mantle, round bottom flask, crude drug powder from which we have to isolate our volatile oil, water. We need to remember that in this assembly water is not used as a solvent. It is used as a heating medium. It will not dissolve the volatile oil. Next part is porcelain pieces. A minimum of 3 to 5 porcelain pieces are required. Next part and the main part of this assembly is clevenger assembly. You can see here the clevenger assembly is of two types. First one is this H-shape assembly and the second type is this N-shape assembly. The H-shape assembly is used for the isolation of volatile oils which are heavier than water. Almost 99% of volatile oils are lighter than water, but in some cases like in case of clove oil, it is heavier than water as it has a specific gravity of 1.042 and that of water is 1. So in that case we can use this assembly. Otherwise, in case of other crude drugs, we can isolate the volatile oil by using this N type of assembly. Next part is condenser. In this we need to remember that the inlet of water is from the beneath of this condenser and outlet should be from the top of this condenser just to maintain the continuous level of water inside the condenser. One of my assembly is already running here. You can see here the water is boiling along with the crude drug and vapors are flowing freely in a single direction. Please note the vapors contains both water as well as volatile oil, and as the vapors are lighter in weight, they directly go to the condenser. The condenser condenses the vapors into the liquid and that liquid trickle down inside this graduated tube in the form of droplets. This graduated tube is connected to a tilted tube. As the level of water rises inside this graduated tube, it also rises in this tilted tube. As we know, the volatile oil and the water are immiscible with each other, so they form separate layers. As the volatile oil is lighter than water in this case, so it will form a layer on the top. You can see here light yellow golden layer is of volatile oil and the layer of water will form at the bottom. As the level of water rises inside this tube, it also rises inside this tilted tube, and as the level rises up to this height, the liquid flow back inside this RBF. In this way, the same water is continuously used for the whole process throughout this process. So after the completion of this process, we can collect our volatile oil from this outlet. This is just like a burette. We can open it and collect. First of all, we will release the water layer, and after that we will collect our volatile oil. Thank you.